All right, let's talk about a problem that, honestly, is a good problem to have. It's the moment your project starts getting so successful, so big, that your single Git repository just feels, well, a little cramped. You've got shared libraries, a bunch of different services, and suddenly you need a new game plan. So today, we're going to dive into the two main ways to solve these growing pains: Git submodules and monorepos.
So let me just ask you this straight up. Is your project getting too big for one repo? I mean, if you've ever found yourself in a tangled mess of dependencies, or if coordinating one small change across multiple services feels like a massive headache, you're in the right place. It's a sign that things are going well, but it's also a sign you need a real strategy.
You know, maybe some of these scenarios hit a little too close to home. Like, you've got this one core library that every single one of your apps uses, and just keeping it in sync feels like a full-time job. Or maybe you're all in on microservices, but now you're looking at dozens of them and wondering, should these all live in separate houses? And a classic one, you rely on some open source project, and you absolutely have to lock it to a specific version. These are the exact headaches we're talking about, and the choice you make here is going to totally define how your team works together.
Okay, so solution number one is Git Submodules. I really like this analogy. Think of your dependencies as independent specialists. You know, they're experts in their field, they have their own history, their own workspace. Your main project doesn't try to manage them, it just keeps a link to their work and says, hey, I need you for this part. So what is a submodule, really? Well, at its heart, it's just a Git repo living inside another Git repo. The best way to think about it is like a package manager, say npm or pip, but one that's built right into Git itself. You're not pulling from some external registry, you're just telling your main repository, hey, for this folder right here, I want you to check out the code from this other Git repository. It's all native Git, which is pretty cool. Now, this approach comes with a pretty classic trade-off. On the one hand, you get this really clean separation. Your shared library gets to live its own life with its own versioning. This is awesome because it decouples your development. A change in the library doesn't have to immediately affect your main app. But, and it's a big but, the flip side is complexity. The workflow for cloning and updating is different, and it absolutely requires your whole team to be on the same page and, well, disciplined.
Okay, this is the most important thing to understand about submodules. Your main project, the parent repo, does not store a copy of the submodule's code. No way. All it stores is a single piece of information, a pointer. It's a reference to one specific commit hash in the submodule's repository. And that pointer, along with the submodule's URL, gets tracked in this little text file called .gitmodules.
So how do you actually add one? It's really just a two-step dance. First, you run git submodule add, and you point it to the repository you want to bring in. Git then creates that .gitmodules file for you and stages this special kind of link. Then you just commit it, and that's it. You've officially linked the two projects together.
And here's the part that trips up almost every team at first. A new developer joins, they run a regular Git clone, and the submodule folder is completely empty, and they're thinking, what happened? Well, remember, they only cloned the link, not the code itself. To actually get the code, you either have to clone with a special flag, -recursive, or you have to run a second command, git submodule update -init, right after you clone. It's an extra step for sure, but it's a crucial one.
Updating is a similar two-step process. So let's say a new version of your shared library comes out. First, you cd right into the submodules folder, and you just do a normal git pull. Great, the folder now has the new code. But your main project is still pointing at the old commit, so you have to cd back up to the parent, and you'll see a change waiting. When you commit that change, all you're doing is updating the pointer. You're telling the main repo, okay, from now on, point to this new commit instead.
All right, let's completely switch gears and look at a totally different way of thinking. This is our second solution, the monorepo. If submodules are about hiring a bunch of independent specialists, a monorepo is about bringing the entire family to live under one roof. Everybody's together, they share the same address, and they're all part of one big shared history.
A monorepo, which is just short for monolithic repository, is exactly what it sounds like. It's one single, massive Git repository that holds lots of different projects that could, in theory, live on their own. You could have your API, your web app, and your component library all sitting in different folders, but they all share one single Git history. This is the model that giants like Google and Facebook use to manage their absolutely enormous code bases.
And this really gets to the core of why you'd use a monorepo. The biggest advantage, by far, is having a single source of truth. All the code is in one place, which makes big, sweeping changes, refactoring, so much simpler. This leads to what we call atomic commits. It means you can change a function in a shared library and update all the apps that use it in one single commit. One change, one commit. Everything's in sync. Now, the downsides are usually about scale. The repo can get huge, which can slow things down, and figuring out permissions can get complicated.
Let's be real, a monorepo without rules is just chaos. It's a mess. To make it work, you need some strict best practices. That means a super clear folder structure, like putting all your reusable code in a packages folder and your actual applications in an apps folder. And it especially means you have to use modern tooling. Tools like NX, TurboRepo, or Lerna are pretty much non-negotiable. They're smart enough to see what you changed and only rebuild or retest the parts of the codebase that were actually affected. Without them, you'd be rebuilding everything, all the time.
Okay, so we've looked at the two big options, the specialist submodules and the family reunion monorepo. So, how on earth do you choose? Well, let's walk through a little decision tree that should help you figure out what makes the most sense for your project and your team.
First question, and it's probably the most important one. Who owns this code? Are we talking about an external open source library or something managed by a totally separate team with their own release schedule that you have no control over? If the answer is yes, then you can pretty much stop right here. A submodule is almost always the right call. It respects that boundary of ownership. Okay, but what if you do control the code? The next thing to ask is about its lifecycle. Does that shared library need its own version number, like V1, V2, V2.1, that's completely separate from the apps using it? If you need to be able to say, this app here is on library version 1.5, but that other one is still on 1.2, then again, that points you straight back to submodules. Their separated nature is perfect for that.
But if you control the code and you want everything to move together, well, that brings us to the final question. How much do you value atomic refactoring? I mean, if the thought of changing a component in your library and seeing that change instantly update across your web app, your API, and everything else in a single commit, if that sounds like an absolute dream come true, then my friend, you have just found the killer feature of a monorepo.
So as we start to wrap this up, I want you to think of this decision as something more than just a technical choice. It's really a reflection of your team's philosophy. The blueprint you choose is going to shape your daily workflow, how you communicate, and how you collaborate for a long, long time.
So if you're going to remember anything, remember this. Use submodules when you're dealing with external code you don't control or code that needs its own independent life and versioning. Use monorepos for your internal projects that are really tightly connected and benefit from moving forward together. At the end of the day, it's a trade-off. Submodules introduce some workflow complexity, while monorepos demand a ton of organizational discipline.
And that leaves us with one last thing to think about. This choice between submodules and monorepos, it isn't just about Git commands. It's about your team's identity. Do you see yourselves as a collection of decoupled specialists, each an expert in your own domain, interacting through clear contracts? Or are you a single, unified family, all living under one roof, working together on a shared mission? The answer to that question might just tell you everything you need to know. Thanks for tuning in.